So we are going to solve a linear system of inequalities, and this will require graphing two lines since our system involves two inequalities here, and it will involve shading. If we notice, these two are not in standard form, and so we want to rearrange these in some way so that they look similar and will be easier to graph. What I'm going to do is, instead of doing standard form, I'm going to go for something that looks more like a slope-intercept form so that I can see what my slope is going to be on each of my lines and also what each of my intercepts should be as I graph this over on my Cartesian plane. So I'm going to take a look at this first one and pull it off to the side and work through it, and then I'll take a look at the second one, pull it off to the side and work on it. So maybe to make this a little easier, I will number each one of these inequalities so that we can keep track of where we are in this process. So I've numbered each of these, and I'm going to take a look at the first one here. So inequality number 1, I have negative 5/3 y plus 3 is less than 7x. So the first thing I'm going to do is I'm going to move this 3 to the right hand side to get it away from the y. Since it's being added to the y, I'm going to subtract it from both sides. So now I've subtracted 3 from both sides, and I need to get rid of this 5/3. So I'm going to multiply by the reciprocal of this fraction, and we want to remember that multiplying by reciprocal gives us 1. This is negative, so our reciprocal will also be negative, and that's going to force a sign switch on our inequality. So that's the next thing that we need to do. Everything multiplied by the reciprocal of negative 5/3. So written out, we have this going on here, and so we need to come back in here and simplify. Y is going to be left alone. It's 1 times y. We're going to end up with negative 21/5 x, and then this is going to be 9/5 there. So this slope is 4.2. So we have 4 2/10, and then our intercept is at 1 8/10. So we're not on integers, so it's a little tricky, but we can do this. So when we come over here and we look at our axis here, our intercept is at 1 8/10. Let's scale this by 2 on each of these, just so we can fit this all in here. And so we are just shy of this first. Our rise over run is going to be negative 4.2 over 1. And so our second point is going to be down here. Here's our second point, and we're going to bring our ruler in here. Since this is strictly greater than, we need a dotted line over here when we put this in. Okay, we have our dotted line in here, and we have to determine which side of this that we're going to shade on. To avoid confusion, it's nice to choose points where your x's and your y's are the same. So we could choose 4, 4. That would be a nice point here. So maybe we'll try 4, 4. So at 4, 4, if we insert that point into this inequality, is this inequality true? If it is true, then we're going to shade all of this. If it is not true, then we will shade the opposite side. We always shade the true side. And so we're going to make a quick check of that. Alright, we are checking the point 4, 4 in this inequality. So for the y and the x, I'm replacing it with the value 4. So I have 4 is greater than negative 21/5 times 4 plus 9/5. And we need to simplify this. So 4 times 21/5, and this is negative, and then we will add it to the 9/5 and see if this right-hand side is indeed smaller than 4. As we simplify our fraction -75/5, we have -15. 4 is greater than -15, and we could have seen this from the fact that we had a negative number here, but this is clear to have the integers here. So 4 greater than -15, that is true. So we want to shade the point 4 and its neighborhood. So when we move back to the graph over here, we want to shade everything over here. This is all true. And now we need to go back and look at the second inequality and do the same process. Alright, I have the second equation written out here. I'm going to move this y over to the left-hand side. Since it's a subtraction here, I can add it to both sides, and I'll have a positive y over here. And then I'll go ahead and I will subtract this 16x from both sides so that we move the 16x over to the right-hand side. And at this point, we have a slope-intercept form, and we can go ahead and graph this over here on the same Cartesian coordinate plane that we've graphed the other inequality on, and we will pick a point and test it in this as well to see where we want to shade. So our next step is to graph this over here. This is strictly y greater than this right-hand side, so again we will have a dotted line over here. Our intercept is -23, so we're going to be down here, and then our slope is -16/1 for our rise over run. Alright, we have our second line drawn in here, dotted. It's in red this time, so we can see a visual difference between the first one in this darker color and this brighter red here. And I'm just going to go ahead and reuse this 0.44. It is to the same side as the previous line as well as the new line. It's neither one of these points intersect with 4, so it's a very valid point to use. And we can just reuse it for consistency, though I could have chosen any point over here to test. But we'll go ahead and we will check 0.44. And so I've already set this up. Y is replaced with 4, x is replaced with 4. And so we're going to have -16 times 4. And that's going to give us -64. And we're going to subtract 23 from that. At this point, we can already tell that this is going to be true as well. This is negative minus negative, which is just going to give us a larger magnitude of a negative number, and so a negative number is smaller than a positive number. So this again is going to be true. We can go ahead and finish this statement though. We're going to have -87 here. So we are going to shade the right-hand side of our dotted red line. And so the real solution to this problem as we shade this in is where we have double shaded. So the region that we double shade is between the intersection point up here down. So we have this little pi wedge here that is double shaded. Right in between the lines is our double shading up in here. That is actually the solution to the linear system that we started. This double shading, any point in the double shaded region will make both these two statements true simultaneously. And that is the true solution to a linear system of inequalities.